Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, for today we will proceed with the last lecture of this semester, that is kinetics. And today motivational quote is and remember, when your Lord proclaim, if you give thanks by accepting faith and worshipping none but Allah, I will give you more of blessing. But if you are thankless, verily my punishment is indeed severe. By Surah Ibrahim, verse 7. Okay. Okay, before we proceed with what is kinetics, so let's recap what you have learned in static and dynamics course. So basically, static and dynamics is mechanics, the lecture on mechanics of materials. So we have static and dynamics. And for static is for statics mean at rest, and or the motion with no acceleration. Okay, and dynamic is for the motion. And in static, you have learned about forces, 2D and 3D forces, and you also learn about moment, moment in 2D and 3D, where moment equal F dot D or F cross R. And you also learn about the reaction at the support. And for the motion, there are two parts of motion, that is kinetics and kinematics and kinetics. And for kinetics is more about the motion without consider the mass. There are three parts of kinematics, that is rectilinear, that is the straight path, curvilinear or curvy path, and relative motion, that is the it's relative to each other. And for the another types of another category of dynamics is kinetic, where you will learn today. It is more on the causes of the motion. Okay, as introduction, kinetic is another branch of classical mechanics, lot more connected to the fundamental law of classical mechanics, that is Newton's second law. Okay, you can remember what is Newton's second law? Yes, the Newton's second law is F equal ma. This is because it takes into account the causes for different motion of the body. So for kinetic, it's related to the causes, so which can be forces or torques in case of rotational motion. But for static dynamics, it's only cover the forces, not cover the torques. Okay, kinetics is actually an older term that was used before the 20th century to describe this area of physics. Later, it was decided that the term sounds too similar to kinematics, and the term dynamics was introduced for the same purpose. Okay, so for if you see some book use this as dynamic. That means dynamics somehow refer to kinetics. Both the term kinetics and dynamics describe the same area of physics, so it's related to F equal ma. And okay, so you just finished about kinematics, so let's review what is the difference between kinematics and kinetics. Okay, kinematic is the branch that focuses on describing the motion of bodies. So it's mainly deal with calculating the velocity, acceleration, uh, and also position. That is, it describes the motion. But for kinetics, it's deal with where those velocity and acceleration are coming from. Okay, so for kinematics, it's not consider where the velocity and acceleration coming from. It's only describe the motion. But for kinetics, it deals with where those velocity and acceleration are coming from, meaning different forces or torques that are applied to those points, body or system of body. Okay, so for example, you have car, and this car move with the velocity of 10 meter per second. Okay, for the kinematics, it's only consider the velocity, the start and end point, and acceleration. But for the kinetics, it's deal with where those velocity and acceleration are coming from. So this one have the velocity of 10 meter per second. How this okay, and we have A. So it's come from this car, and this car have M. So it's considered the mass. Okay, another important difference is whether mass is considered. Okay, this is what I described before. Namely, kinetic doesn't take into account the mass of each body, but rather just calculate their position over time. But kinetics also takes into account varying mass of bodies. Okay, so for kinematic, so for the mass, it's not considered, but for kinetics, it's considered the mass. For example, here we have okay, this one is for the potential energy. Okay, because for kinetic, there are one of the techniques to solve is using energy. Okay, for this, for example, we have here for kinematic only consider x, y, where is it's maybe s or v or a, and this one t or s. Okay, so kinetic is the study of forces that are acting on an object under a particular mechanism. So this is considered the force that are acting. But for kinematics, is the branch of mechanics concerned with the motion. It's more concerned on the motion of object, without reference to the forces which cause the motion. So it's for kinetic consider the force, but for kinematic not consider the force. Okay, kinetic focus on the causes of different motion of the object, such as rotational motion, force. So it's considered the causes. But kinematic focus on velocity, acceleration, and position of the object. And kinetic doesn't consider the masses of the object. Okay. Okay, kinetic is the study of the relationship between unbalanced forces and the resulting changes in the motion. And in this chapter, we will study the kinetic of particle. This topic requires that we combine our knowledge of the properties of forces and the kinematic of particle motion previously covered. Okay, previously you have learned about the kinematics, where it's can divide into rectilinear, curvilinear, and relative motion. So for kinetics, it is a combination of kinetics and Newton's second law. Okay, with the aid of Newton's second law, we can combine these two topics and solve engineering problems involve force, mass, and motion. Okay, why second law? Okay, let's look back. What is the Newton's law stated? Okay, for the first law, every object in state of uniform motion will remain in the state of motion unless an external force acts on it. Okay, so for the first law, in a state of uniform motion with means that we have constant v. The velocity is constant, so the acceleration is zero. So there are no acceleration. And for the second law, force equal mass time acceleration. Okay, this one is F equal ma. And for the third law, for every action, there is an equal and opposite reaction. Okay, for this one is it's considered action and reaction. Not consider the motion. Okay, Newton's first law and third law are sufficient for studying bodies at rest or bodies in motion with no acceleration. Okay, this one action and reaction is at rest. And for so this one is constant velocity, there is no acceleration. That's why for kinetics we deal with second law Newton's second law, because Newton's second law state that F equal to ma. Therefore, for motion particle, Newton's second law is applied. So we use this equation for the kinetics. Okay, for example, here we have particle and we have two forces act on this particle, F1 and F2, and the resultant forces is Fr. So it can be write in kinetic diagram this equal ma, because it have acceleration toward left. Okay, for this, the equation of motion has to be applied in such way that the measurement of the acceleration are made from a Newtonian or inertial frame of reference. This coordinate does not rotate and it is fixed or translate in a given direction with a constant velocity. So this is the remark for this equation of motion. Okay, there are three general approach to the solution of kinetics problem. The first one is force and acceleration. The second one is work and energy. And the third one is impulse and momentum. But for this syllabus only cover the force and acceleration, not cover work and energy and impulse and momentum. Okay, to solve the kinetic problems, we can use free body diagram and F equal ma. Okay, for the first one, we need to identify all the relevant forces by drawing the free body diagram of the particles, and then Okay, draw the boundary of the chosen section and detach or separate it from all another particle. Okay, and then put all external forces acting on the particle. Then, for a particle with a mass, put the weight equal mg. So W equal mg, acting toward vertically downward. And for the particle touching the surface, for example here, touching the surface, there is a normal forces acting perpendicularly to the surface. So we have surface here. But if the surface like this, at this one and like this, that is perpendicular to the surface. And for the problem involve friction, the friction force F equal m mu n tangent to the surface of the contact and against the direction of motion. Okay, for example, you have box like this, and the friction tangent to the surface. Tangent means like this. This one equal and against the direction. For example, this box, the velocity is toward down, but the friction is toward up. Okay, for the combination of kinematics and Newton's law, we have, for example, for rectilinear motion. Rectilinear motion is only one dimension. So we only have in the x-axis, for example, from one point to the another point. Therefore, the force is equal Fx is equal max. So there are no forces on the y-axis. But for the curvilinear, there are rectangular coordinate, normal and tangent coordinate, and polar coordinate. So this one is for all, because this one is xy. Like this. Okay. And t and r theta. R theta. Okay, so this one is how you need to use the equation and put the ma into the equation. Okay, let's look for. Okay, let's try this example. Determines the required horizontal force P to initiate the 10 kilogram mass to move up the 30-degree incline with an acceleration of 2 meter per second squared. So the given is mu. Mu is friction coefficient 0.2. Okay, and then the m equal 10 kilogram. So we have W here, W equal mg, and then we also have normal force that is perpendicular to the surface. We have surface here, so perpendicular to the surface, and then mu is the okay. We have the force here, so this mass will move like this with the velocity toward up. So the friction coefficient for the friction force is equal mu n. And then okay, here F equal given parameter. Okay, it is like this. So we have this one is W equal mg, m is 10 and g is 9.81, and then we have n toward up perpendicular to the surface, and then this is the friction friction coefficient times n. Okay, so this is we have the mass here, and then put the all external forces. We have W, F, friction, and normal. So from here you can get this mass, it can divide by this. So we can assume this is x and this is y. So for the x-axis, so we have p cos 30 minus, because this one is w here, okay, this one is w sin 30 with the negative direction because it's toward left. So we have w sin 30 is there, and then 0 negative 0.2 n is the friction. So this is the mu and friction coefficient, and equal to this one is ma. Okay, so because for this one we have all the parameter here, and it equal the ma. So we will get the first equation 0.866p minus 0.2 n equal 69.05. This is the first equation, and for the second equation is y-axis. So we have negative p sin 30. Okay, negative p because for here we have this one is p cos 30 and another one is p sin 30. So toward bottom, and then the weight also, okay, this one is w, so this one is w cos 30, so also toward bottom, and then plus n equal 0. So from both equation, you solve the equation, you will get the force P is equal 112.3 Newton. Okay, that's all for this lecture. Till we meet again